Hey everyone, today we'll be doing the POTD for 18th of October, which is maximum number of distinct elements after operations. So we are given an integer array nums and an integer k, and we are allowed to perform the following operation on each element of the array at most once. We can add an integer in the range minus k to k to the element, and we have to return the maximum possible number of distinct elements in nums after performing the operations. So basically we have a range, and the range is so the range is minus k to k, and we can add an integer in this range to any element, and in the end, after performing some operations, we need to tell the maximum number of distinct elements after the operations. So let's think about it. Okay, so let's just say that we have an array and we can add some elements to it. So obviously okay, so one thing about it is that let's say array is sorted. So for example, we have an array like 1 1 2 2 1 2 3 4 4 4 and then 10 9, and let's just say our k is in the range 0. So one edge case that we are going to figure out is that so basically if we don't have a k, then obviously we are going to return, first of all, let's just say that we have a set that consists of nums.begin and nums.end. So this will contain all the distinct elements that are present in the nums, and we just return the set of the size of the set. Why is that? Because when k is 0, then that means that we cannot do any operation, because minus 0 to 0 means literally just doing nothing. So if k is 0, then we just return the size of the set which contains the number of distinct elements. But if k is not 0, for example k is even 1, then we can see in our sorted array, what we can see is that the distinct elements stay distinct. Okay, and even if we add +1 to them, we might change the order. For example, we can have 1 1 2. So if we add a +1 to this guy, we'll make this 2, and yeah, so doing that would be not beneficial for us. So what we are going to do is we are going to do a subtract operation on the elements, and we're just trying to see if you are able to formulate the values. So one thing about it is that let's start with the smallest elements first. So let's just say our k is 2, right? So we can do this operation in -2 to 2 range. So when we try to do that, first of all we are going to add -2 to the 1, so it will become -1, and then we'll add a -1 to 1, so that will come 0, and then we'll add a minus. So we're not going to add a -2 because we already have 0. So what we are going to do is just do -1 something. So when we so we're just going to add -1, so that would become 1. And yeah, so basically we have to do operations in such a way that we have a window. So the window is from -k to k, and we can add elements in such a way that they don't intersect with each other. So what are we going to do? First of all, we'll have certain amount of okay, cool. Okay, I got it. So what we are going to do is, first of all, let's just say that we have certain elements. Okay, so yeah, so let's just say that what we are going to do is we are going to store the frequency of all these elements. So let's just say that if we collide this array into its unique elements, so it will become 1 2 3 4 10 and 9. Okay, so all these elements are unique, so currently we have 6 unique elements. So what we want to do is, obviously, changing them would just mean that we if we are adding or subtracting the same k from them, that would do nothing to us, that would do nothing for us. So what we are going to do is what we are going to do is basically, let's just say that we add the highest k to all of them. So I'm doing that only on the first element, so it will become 3, then we'll have 1, then we'll have 4, then we'll have 5, then we'll have 6, and then we'll have 4 and 4, and then we'll have 12, and then we'll let's just say that 9 was before because we have a sorted order, so then we'll have 11, and then we'll have 12. So we have all these elements. Now what I'm going to do is basically we are going to add elements to these starting from -2. So what we are going to do is we are going to add a -2 here, so it will become a -1. And since this element was changed, we won't do anything for this. Yeah, so we are going to add a -1 here, and then we're going to go ahead and we're going to see, then we're going to add a -2 here, so it will become 2, and then we're going to add a -1 here, so it will become a 1, and then we do nothing. So as we can see, we have all the distinct elements here. So that's what I am going to do. So first of all, let's just say that we sort the array. So we sort nums. Okay. Okay, so what are we going to do? Basically what we are going to do is in our nums, what we are going to do is that cool. So yeah, okay. Yeah, so what are we going to do? We are going to create a set, and we are going to iterate through the nums. And what we are going to do now is that if s dot find of nums of I double equals s dot n, then we are going to add a plus k to the nums. Okay, and then we're also going to insert nums. Okay, so what this does is we can just see it. Let's just say we're returning 0 something. Okay, so we can see that what it does. Yeah, so what it basically does is it gives us these values. So basically 1 becomes 3, 2 becomes 4, and then it should not have become 4, but okay. Yeah, I mean it should not have become a 4, but okay. That stays free, which is weird. Oh yeah, we are changing it and then adding it, that's why it's, yeah, so we should change it after, you know. Okay, we didn't change. Cool. So now what we are going to have is these elements. It will become 3. So 1 plus 2 is 3, 2 plus 2 is 4, and we don't change this element because we already have changed this once. 3 plus 2 is 5, we don't change this, and 4 plus 2 is 6. So now what we are going to do is what we are going to do is basically, we are going to, you know, yeah. So now what we're going to do is we're going to create a map, let's just say. So this is the map, and then we are going to go, um, or otherwise we can say that else we can create the map here itself. So if we have seen that element, um, so what we're going to do is basically, so cool. So basically we are going to add these values to it, and then we are going to subtract minus k from each of the following similar elements. So otherwise, if we have seen it, then what we are going to do is, so we have seen it, right? So it would be, so we can assign it a minus k here. So we can assign it minus k here, and then what we are going to do is we are going to subtract nums of I, and in relation to this we are also going to reduce it. So by reducing it, we'll increase it actually. So by increasing it, we'll have minus k plus 1, which falls in the range. So yeah, we are going to basically do this, and then in the end what we are going to do is we are going to create a set. Let's just say we just do an s.clear, and then we just do for rather x in nums, s.insert nums of I, or basically x, and then we can just return the size of the set. So a couple of things we can do here is we can remove this. I don't think we require this, and also we can make both of them unordered because we don't really care about the order. So we're going to do that, and yeah, let's see if it works. Okay, it didn't work. Sure. So what we are going to do here, what we are doing wrong. Okay, let's see. So in nums what we have is this becomes 3, this becomes 4, this stays 2, which should not be the case. It should have subtracted itself. Nums of I minus p of nums of I. I think this is fine. This is not wrong in any ways. Oh, okay, we have to add it here. So now I think it should work. Basically we have to add it because we are assigning it a minus k. Let's see if it works. Oh, I'm actually adding a complexity here. Yeah, it won't work like this. Okay, so yeah, that was actually helpful. All right, so they expected a 10 here, and the size of the array is also 10. Interesting. So they must have increased these values. Yeah, so they must have added a 3, 2 and 1. Yeah, I mean we could do that. Just add a 3 to 1, and then 3 to 1, 3 to 1, 3 to 1 or something. Yeah, I mean we could do that. That is also doable, or we could also do a minus 3. Let's just see what we can do. So we have 1 1 1 1 7 times. I think that's 7 5 5 and 5. So what we can do is we can subtract a -3 from this, so it will become a -2. And we can subtract -2 from this. So subtracting a -2 from this basically makes it, you know, -1. Then we can subtract a -1 from this, becomes 0. Then we can add a 0 to this becomes 1. Then we can add a 1, then becomes 2. We can add a 2, this becomes 3. And then we can add a 3, this becomes 4. We can add a 1 6. Okay, we can do that. We can do that. Okay, I got it. So technically what we have to do, okay, there's an easy solution for this. Okay, so yeah, so let's just start it. So we're going to go inside our map, and then what we're going to do is we're going to create a value which is a -k, and we're going to go for all the frequencies in the map. Okay, all right, so we are only going to reach till minus, so it might happen that they have more frequency than k, and in that case we can't really do anything. So but it might happen that we also end up making you know, similar elements. But would it happen? Yeah, there is a possibility, but we are also reducing them. But that's just like saying we are doing the same operation with everyone. Okay. This is a good problem. Yeah, not a very good acceptance rate also. This is a good problem. I think we can solve it. Just have to think more, I guess. Maximum possible number of distinct elements and norms after performing the operations. So it's more like we can reduce this one, but then it might happen that we never reached. It might be so the difference might be big, you know. So well, okay, sure. So but in that case it worked for us because we are increasing the other values by 1 2 3, and we do that because we do that because let's just see this. So we add a 3 here, which should not. Okay, we add a 3 here, and then we should have subtracted a -k from this. Okay, it should have become a -4. um all right. So we are going inside the map, and then if we find the number which we didn't first type, but then we are also making the map store the value of nums of. Oh, that's why it's. Oh my god, that's why it didn't work. I'm doing that after doing the operation. Still, it's a -8. So we add a 4. We add a -3. This works for us. Then we are adding a 1, a 2, and a 3. Okay. And then we're doing the same thing for 5, which might lead to. Well, one thing we can do is try to add smaller values to the smaller values. And then add bigger values to bigger values. Okay, I got it. Yeah, I got it. Yeah, I got it. So if K hits that, we don't really have a choice. And if we have already seen the value, we don't really do anything with that K. We just increment it. But we can't really increment it. That would take. So we can do a binary search on the incrementation. What we can do is find the smallest K such that okay, we can we can do this in a long way. Yeah, so we can just do. Alright, man. Now I am actually pissed off. So, you know, this problem is annoying me now, but we're going to solve it anyways. Okay, so what we are going to do is basically we are going to find out the smallest K. So so we're going to find that out. So L is equals to minus K minus 1 and R equals to K plus 1. That makes them include their range. Then we're going to do and we're just going to see that our value is our nums of I plus M, and we just see that if MP of val if MP dot find val double equals MP dot N, which means that the value does not exist. Yeah, so if the value does not exist, then what we need is we need to find the smallest K, right? So we just do R equals M, else we have to increase L, and then we just see that if R double equals K plus 1, we just continue. Otherwise we just do MP of nums of basically nums of I plus r equals true or something, and then in the end we can just return um, yeah, we can do that, and also we can just add r to it, and then we can form a set. Yeah, I mean, yeah, whatever, just gonna form a long one, but that's an infinite, and this is going to be a set of all the nums values, and in the end we can just return s. Yeah, this might work. This is a slower solution. I was trying it off, and yeah, it worked. So we just did a binary search, but I wasn't trying for this, but I didn't have any choice. I'm not able to formulate an OFN. There must be an OFN solution also, and yeah, they don't use binary search, but I did. Yes, we sorted this, but we didn't actually use anything. Well, it is useful actually. And the minimum element, which is not, yeah. So the thing is that we can use a greedy way to find out the minimum element that has not been used, but I used a binary search, that's why it's low. So maybe we can use an O of one thing inside here, find that out. But yeah, I'm too lazy right now, so yeah. That's all. Bye.